In this video, we're going to discuss CRA models for decimal place value concepts. We're going to use the base 10 blocks, and I have a place value mat here as well. And we're going to kind of try to connect this to some of the fraction understanding, because decimals are just a specific case of fractions, right? So it's just another way to think of a decimal is a fraction where our denominator is a power of 10. Right? So either tenths or hundredths or thousandths or 10,000ths and so on. So how we can use these base 10 blocks for decimals is just by changing what the value of 1 is equal to. So with whole numbers, we had said this was equal to 1. So that makes this the tens place, that makes this the hundreds place, and so on. So with our decimals, it's common to use what was formerly the hundreds place or the hundreds block as being equal to 1. So we could use others, but I'll just kind of show the example for this. So this is now equal to 1. We're saying this is our whole. Right? If we're kind of using that fraction logic again, right? Then one of these strips, right, it would take 10 of these equally sized parts, right, to make up one whole. So that means each of these is 1/10 of the whole, right? So this is our ones place, then this is our tenths place, right? Each of these represents 1/10 of the whole. Kind of similarly, it would, from these smaller cubes, right, it would take 100 of these units to fill up this entire 1 over here now. Okay, so that means each of these small cubes is 1/100th of this larger square. Okay. So now kind of using this, right, then we can kind of use that to model decimals. Okay, so we're going to look just at concrete, representational, and then abstract all for the same one here. And then I kind of want to quickly show just a different one and kind of relate that to the language that we use with decimals. So again, if I'm saying that this unit here is equal to 1, if this is my decimal I've represented. So here I have 3/10ths and then 5/100ths. Okay, and how we would read this generally is going to be 35/100ths, because we could also think of these 3/10ths as 30/100ths, and just generally how we read these is in regard to the smallest place value. So rather than saying 3/10ths and 5/100ths, we would just say 35/100ths. Okay, so this is a concrete model for 35/100ths. A representational model, we would generally probably use a printed version. I didn't have a printed version for this, so I just drew one. Obviously, a printed version is going to be a little bit more precise, more actually drawn to scale. But we would just show a full 10 by 10 grid. And again, you would have 35 of those hundredths shaded in. So this would be a representational model, just any kind of image or drawing, essentially kind of replicating, in this case, our full hundreds, what was formerly the hundreds unit. And then for the abstract model, we have some different variations. Okay, so this is kind of our decimal notation. So again, we had 0, 1s here. Oftentimes we'll write our ones place value there, just so that decimal point doesn't stick out too much. But this decimal point is how we are separating our whole numbers from our kind of fractional components, right? These are all whole number values to the left here. These are all tenths, hundredths, thousandths, and so on. So this decimal point is how we separate that. Okay, and then in that tenths place value, right, we had 3, so we're at the 3 there. In the hundredths place value, we had 5, so we're at the 5 there, and it would extend kind of indefinitely to the right as well. Okay, so that's kind of our number form, our word form, again, whether this is written or spoken, right? How we would read this is 35/100ths. This, and then these last two are two different variations of our expanded form, right? So we might have 0, 1s, right, plus 3/10ths plus 5/100ths. And then here we're actually multiplying it by the place value. So 0 times 1 plus 3 times 1/10 plus 5 times 1/100th. Okay. So there's multiple variations we could use for the expanded form here. We could kind of connect it to fractions as well, right? We could write the 1/10 and the 1/100ths as fractions. We could also write this using kind of the exponent form. And this could be times 10 to the 0 power, times 10 to the negative first power, times 10 to the negative second power. So there's kind of some different variations we could use there. And then just really quickly, I want to show, right, so let's say this is our model. This is just kind of one note I want to make. Right. So if this is our concrete model, right, we have 1, and then we have 1, 1, we have 3/10, and we have 5/100ths. I'm not going to show the representational model, but it would be similar to the previous one, but we just have one full 10 by 10 grid as well. With our notation here, right, again, I said all the whole numbers go to the left of that decimal point. And then our word form, I have enough room here, be 1 and 35/100ths, okay? So this is when the word and comes into play, is when we have these fractional pieces. So either in decimal form or in that mixed number form with fractions. All right, this is where that and comes in. So again, we previously talked about if we have the number 107, we don't want to say 107 because we want to save that word and to designate the decimal point. Okay, so kind of similarly, if we had a mixed number, right, of 1 and a half, again, our word form would be 1 and 1/2. So that and is kind of supposed to align with that decimal point there. Okay, so that's how we can kind of use some of our, some of our existing models, right? Use our base 10 blocks, even though we're not using whole numbers necessarily for all of our pieces. But that we can use that as our concrete model. Representational model is often going to be that 10 by 10 grid, and then again with our abstract model, we'll have some of those different number forms. So there, that model is going to be our digits, symbols, and then actual words as well.